Welcome back, my adoring listeners, to Technology Blows. I continue to be your host, armchair engineer Dan Sliman, and I'm here with my guest for part 2 of this episode on wireless headphones. Guest, who do you continue to be?
This is Steven Lauk. How are you? Thanks for having me again.
Wouldn't dream of depriving you of the story of the rest of the headphone evolution. If you're just jumping in now without listening to part 1, stop. What are you doing? Go back. You probably don't even know what headphones are. Go back and listen to part 1. Sheesh. All right, Steve. We don't have time to talk about dog shit or Mark Zuckerberg's dumb glasses today, so I'm just going to get into it. As you know, in part 1, we went through the story of headphones up to the 1980s, when the advent of the Sony Walkman transformed every city into a million little separate interactive music videos. But the invention of the Walkman wasn't the only earth-shattering development that the 1980s had in store for our tragic hero, the headphone, because do you know what the Federal Communications Commission did on May 9th, 1985?
Besides, wearing neon clothes or using Aquanet.
It was the neon had harmonics as interfering with air traffic. They deregulated the 2.4 gigahertz band for spread spectrum communications. You heard of this thing? 2.4 gigahertz band?
Yeah, it's like the thing that's you're always helping your grandma with, or your neighbor.
Yeah. Grandma, yeah, you got to get on the 5 gigahertz band.
Yeah, grandma.
It's twice as many gigahertz, more than twice. So the 2.4 gigahertz band for spread spectrum communication, we'll talk about what that means, but it's hugely momentous. Without this, wireless headphones as we know them would not exist. And if things had gone differently with this deregulation, wireless headphones might not have ended up being such pieces of shit. So ever since the invention of radio, the US government has asserted ownership over the entire broadcast radio spectrum within its borders, which doesn't make a lot of sense intuitively, right? The spectrum is just the set of frequencies that radio waves can have. How can you own it? How can anyone own it, right? Can you own the rainbow? And yet, through the magic of the legal and bureaucratic apparatus, our society has made it possible to own all sorts of things that don't make sense to own. This is one of the main jobs, maybe the main job, of jurisprudence in the capitalist state, figuring out how to take all kinds of wildly different situations and turn them into questions of property rights. So before we talk about how the 2.4 gigahertz band got deregulated, I want to talk a bit about how radio got regulated in the United States in the first place. The fundamental reason, the physical reason that we invented broadcast spectrum regulation is interference. Interference is what happens when a radio signal gets mixed together with other radio signals and EM waves, such that the desired signal can't be pulled back out in its pristine form. And interference destroys information. So for example, say I'm an angsty teenager living in Jacksonville, Florida in, say, 2001, and I tune into Planet Radio 93.3, which is the alternative rock station in town, and I'm driving along listening to all those alternative hits I crave, like Audio Slaves, Like a Stone, and Marilyn Manson's The Dope Show. And I start to notice this sort of like tinny sound coming through, layered on top of what I'm listening to. But instead of being badass alt rock, it's fucking Livin' La Vida Loca or whatever. That's interference. I'm picking up Planet Radio 93.3, but I'm also picking up bits of some other station that's transmitting on the same frequency from like Ocala. And my radio can't discern which station is which, so I get noise, interference. We don't really get to
Ricky Martin Manson.
Yeah.
Ricky Martin Manson.
Yeah, interference is like all sorts of horrible mashups that you heard one time in a club and never want to hear again.
Exactly.
Interference is a experience we don't get to have. I mean, I don't listen to the radio. Do you? I don't. Basically, never listen to the radio, so we don't experience this anymore. From? But it was.
I was listening to the radio when I ran into your mom at Blockbuster. You're renting a video. What do you mean the radio?
Pause my Walkman. And
I listened to the radio through the internet.
Exactly.
Analog. Analog's what you're kind of talking about.
Yes.
Too, right? I think that's important to call out. This is not through your iPhone, just to make sure, not to date ourselves, but when you say you were listening to the radio, you didn't mean through the internet. You meant through the air. And so this is a thing. Yeah.
That's right.
Sometimes I forget that I have to say this to people.
That's right. But it's important because digital works very differently, and we'll get to that. But yeah, you can transmit sound signals through the air, and in fact, they have built headphones. There were companies building headphones in the 1960s and 70s where there's no wire, they're wireless, but the sound comes through an AM signal from a transmitter that you plug into whatever the player, and it transmits an AM signal.
Yeah. And to be clear, we know how to transmit sound through the air.
Right.
But the important word you said was sound signal. So it's an amplified thing. It's not like you're just playing, the song louder and it's being picked up by a device, right? So this is important that it's a signal, right, through the air, not just the sounds. Like, because otherwise, you just stand near the bands. I mean, that's kind of what
right.
This is standing very far from the bands.
It's right? Like how we used to do it. The band might not even be at the radio station.
They might not even be alive.
That's even truer.
Yeah.
So in the early days of radio in the 1910s, the federal government would grant radio licenses through the Office of the Secretary of Commerce. This is before they had any particular department involved in radio licensing. But by the 1920s, there were still a lot of open questions about whether the federal government even had the authority to withhold radio licenses from people, and what it meant to have a radio license. Were you allowed to... was the government allowed to tell you can only transmit on this frequency if you had that license? And this uncertainty about the federal government's powers culminated in a period from July 1926 to February 1927, where shit was just fucking chaos. To quote from an article by Thomas W. Hazlitt for the Journal of Law and Economics, stations had to be licensed by the Secretary of Commerce. Once licensed, they were free to roam the dial, select their own transmitting location, choose their desired amplification level, and set their own hours. A breakdown of the rights allocation scheme resulted in a predictable and theoretical hindsight chaos. And this period gets referred in the article to as a tragedy of the commons, but I wouldn't necessarily call it. I don't know. It's like a tragedy of the commons is supposed to be everybody's allowed to graze their animals on the same place, and then they eat all the plants, and then you can't graze the animals there anymore. The radio spectrum isn't like that. You can't destroy it by using it. It costs power to broadcast on a particular frequency, and as soon as you stop spending power doing that, that frequency is empty again. It's a resource that renews itself every instant.
Oh, I'll ask this question because this is interesting. Like, this is analog, so it's sort of continuous. So where they literally, like, they're turning a dial. I think that's important. It's not clicking yet. You're just kind of turning the dial, right?
Right.
The clicks are what I'm interested in, like, because how do you decide I guess they measured like 2.4, but it starts being like almost like music notes. Like you could just sing it continuously. Like it's like that. Who decides it's A, B, C, D, starts to divide. This is interesting.
Yeah, very much.
Because
very
I
much
think
so.
This is very much tied to authority, right? Anyway.
It's very much tied to authority,
Okay.
Steve.
Interesting. I can't wait.
The clicks, the clicks, well, I'll probably do an episode on car radios at some point, but the clicks, from the point that FM was regulated, you could have had a clicky type radio that clicks onto stations, because each FM station has a let me do the math. It's like a 100 kilohertz, I think, or 200 kilohertz band. I could have done the math wrong on that. Don't email me. But there's a band around the frequency of you're broadcasting at for your carrier wave. So those are well defined. We know there's only a finite number of stations between 9.1 megahertz and 107.9 megahertz. Anyway, tragedy of the commons. It was chaotic. It made big problems, small problems for people who wanted to listen to the radio, right? You just, if your station's not playing or there's interference, you just listen to a different station. Who cares? But it was big problems for the broadcasters, because if you're trying to run a radio station and everybody's allowed to transmit on any frequency they want, it's really hard to develop a listenership, which is how you sell ads. So all this chaos was ultimately resolved by the 1926 decision in Tribune Company versus Oak Leaves Broadcasting Station. This was a dispute between Tribune Company, that's the company that owns the Chicago Daily Tribune, and Oak Leaves Broadcasting Station. So Tribune owned a radio station called WGN, which had been broadcasting on 990 kilohertz AM. And another company, Oak Leaves, one day just decided to start broadcasting on the same frequency, which is kind of cool. I like that. I like that there was a time you could do that, although it didn't last long, I guess. So they start just broadcasting. I think they were like 40 kilohertz away from WGN's. Like, can you imagine if NPR one day were like, fuck it, we're taking over the country station's frequency. What are those country station pussies going to do? We're NP fucking R.
Yeah, I advocate for this. I think this is amazing. This might cause some people to really think about this. It's like, it's an interesting space, yes.
Yeah.
To fuck with people.
Wouldn't that be great? I've often thought
it doesn't take much.
I've often thought about buying like a directional antenna and a generator and just like going and standing on above the Merritt Parkway where I can see the cars coming in, right?
More cowbell. Just add cowbell to everything.
Oh, that's a great idea.
Like just a cowbell station. But I think the only problem with that is I think we're messing with federal.
Oh yeah, no, it's absolutely out. You absolutely go to jail if you get caught doing that. Yes.
Yeah. This is federal charges.
Yeah.
Just, like,
This is why it's a dream.
It's not just throwing a sandwich.
Yeah.
Oh wait, that was federal.
Nobody wants to go to federal prison. I don't want to go to federal prison. There's a lot of things I'd like to do that would get me in federal prison, and that's why I don't do them. So in this case, in this legal case, the Cook County, Illinois Circuit Court ruled that the, quote, wave jumper, which is an awesome name, Oak Leaves is what that refers to, they had violated the right of WGN to broadcast on WGN's assigned frequency without interference. Essentially that because they were there first, WGN had a property right. It was called a property right in the ether because they believed in the ether back then. And with property comes the right to exclude others from your property.
So is this a place then? Is the spectrum of, this sounds like, is this a place?
It's not a place. It's definitely not a place, but neither is a patent. There are a lot of things that are not property, that are not like land and houses or like objects that are still considered property because it's really convenient to have there's a whole body of common law around what property, what people's rights are with respect to property and how you can pass it to other people and how you can buy and sell it. That if you have some new phenomenon that appears in society like radio broadcasting, it's very convenient if you can just apply that body of property law to the radio, and then there's a lot of things that are just figured out for you.
That's what they did basically, right?
That's what they did.
Applied property law to invisible spectrum
to frequencies of waves.
Frequencies, yeah.
Yeah. Mm-hmm. I don't condone it, but that's how they did it. So this allowed the Federal Radio Commission, which was established in 1927, then the FCC, which supplanted them in 1934. That allowed them to really start carving up the ether like a Christmas goose. If you have this kind of license, you can broadcast on these frequencies at this power. The Coast Guard gets these bands. Nobody else can use those. Cell phone providers get these bands, and so on. And if you've never taken a look at the modern spectrum allocation, I recommend it. I'll put it in the episode notes. It reminds me of nothing so much as the hard drive defrag utility in Windows 95 before you start defragging your hard drive. It's just like so incomprehensibly chopped up. So anyway, this is how it came to be that in the US, you're not allowed to broadcast above a certain power level on any radio frequency unless you have been granted the appropriate license from the FCC. And if you do broadcast without an appropriate license, then jackbooted FCC radio cops come crashing through your windows and vaporize your antenna with their laser guns and take you to radio jail.
Do you think that would happen nowadays? Do you think it's like automated? Like,
I don't want to test it.
I kind of do.
I kind of do.
I want to just see. Because this is, I realize like in talking to some younger people, more in their teens and 20s, that I don't think they have a concept of this, but enforcement of these things also kind of follows the use of these things. And so making fun of the fact that they're going to come down harder because it's so much easier to see that you're blasting over really there's only like the country station or whatever, and they will notice. But if you were to just sort of do that, I think that sort of 80s mindset about it is definitely not the same. So they might not even notice. But
They might not even notice. That I would, my guess would be they kind of leave it to, they monitor maybe the airband or things that are important for security and
maybe auto with notifications.
Yeah,
There's like
maybe
a Nagio server like monitoring radio.
I don't know. I'd love to get an interview with somebody. If you work for the FCC and you're listening to my podcast, I'd love to interview you. You used to work for the FCC, even better. I'd love to get talk to you about that. My guess would be if for FM, like commercial radio stations, they just let the FM stations work it out themselves. If somebody else, and if they find that somebody else is broadcasting on their frequency, then they report it to the FCC or they sue them.
Yeah, they guarantee on the stations themselves monitor. But if you were to blast on something outside the space that is sort of atrophied, I wonder if there's like automated systems or not. That's a really interesting thing. Yeah. Or if it's just like no one would notice, which maybe. Yeah.
How could you detect it? It would be if you're trying to detect the presence of a signal on a broad range of frequencies across a country, right? The signal to noise problem is really tough.
Right. And they tore it all down. Like, so they literally tore down the antennas and stuff and put it all on fiber. So like the broadcasting has been consolidated to certain places, even in the city, because people, the NIMBYs are like, can't have these, like, I don't know what that thing is. It looks big, but I don't want it pointing in my neighborhood, right? Even though it's just a radio tower or something, right?
Right.
But also you could just see that maybe even the broadcast infrastructure has atrophied and maybe not. So there might be, it might be a lot more wide open than people think, kind of like a forgotten thing.
Yeah. Maybe I'll roam the country with a radio scanner and just start broadcasting in my RV from different locations. Yeah. Although nobody will be listening to me. So you need a radio license to transmit above a certain power, and this brings us back to the 2.4 gigahertz band. So the FCC's radio licensing scheme works okay if what you're regulating is radio stations, because setting up a radio station requires a shitload of capital. You need a bunch of complex electronics, you need a big antenna, you need a bunch of staff. It's not a huge extra burden to get a license to get a license from the FCC or to rent somebody's license who has a license from the FCC. However, by the early 80s, the situation has changed quite a lot. Many electronic devices are small enough to fit in your pocket, complex enough to run software, and cheap enough to be mass produced. And these trends, it was almost as obvious to 80s people as it is to us now, were only going to accelerate. But because of the regulation scheme, consumer devices aren't allowed to output radio waves. Right? You need a license for that. Consumers don't have radio licenses. Now, initially, before I researched this episode, I kind of assumed that the impetus for deregulating the 2.4 gigahertz band was that electronics companies were all, clamoring to develop innovative products by combining the exciting technologies of microcontrollers with low power radio transmission, right? That's the picture I had in my head. Absolutely wrong. Here's what actually happened. So in the late 70s, the FCC chairman under President Carter, whose name was Charles Ferris, took the initiative to kick off a search for potential new technologies that could blossom if dated radio regulations were removed. And this led the FCC, over the course of years, to identify something called frequency hopping as a technique that might enable private sector companies to develop new technologies that use radio. All right, so what's frequency hopping? Frequency hopping is a technique for mitigating the effects of radio interference within a given frequency band among non-coordinating broadcasters. So suppose, for the sake of argument, that there's some small portion of the radio frequency spectrum. I'll just pick a random range of frequencies here, totally out of the blue. How about 2.400 to 2.485 gigahertz? And within this band, you want it to be possible for a large number of devices to communicate with each other. And suppose further that the devices can't make any prior arrangements with one another, or the users of the devices can't make any prior arrangements with each other about who's going to use what frequency. They're all allowed to use the whole band, and they can't coordinate. So if you just let all these devices do whatever they want, it's an absolute mess. It's just a clusterfuck, because the first 10 shit for brains that jump in there are just going to look at the band and go for the lowest frequency, 2.4 gigahertz. And then the next 10 shit for brains will be a little smarter, and they'll use the midpoint of the range. And all of these shit for brains will be categorically hosed, because if you're transmitting at 2.400 gigahertz, and as soon as somebody else comes within range of you also transmitting at the same frequency, interference. There goes your link.
Yeah, it's a shit for brains pigeonhole principle, right?
That's right.
It's kind of like a giant mosh pit, but everyone wants to be in the center.
Yeah, and it is a giant I mean, the 2.4 nowadays, the 2.4 gig, it's so tiny. First of all, it's such a tiny little slice of that we're supposed to thank the FCC for of frequencies. It's very, very busy. So what you need, if you're going to have a bunch of devices transmit on the same frequency band and not interfere with each other too much, you need a protocol. And frequency hopping is a protocol. So in frequency hopping, you enforce an agreement among the device manufacturers, not the device users, the manufacturers of the devices that are going to use the band agree to use it in a very specific way. First, you divide up the band into a certain number of channels, usually evenly spaced channels. Bluetooth defines 79 channels, each with a bandwidth of 1 megahertz. So channel 0's central frequency is 2.402 gigahertz, channel 1's is 2.403 gigahertz, and so on. Wi-Fi, just for comparison, it also uses 2.4 gigahertz band, but it has 14 frequency hopping channels spaced 5 megahertz apart. So just different design decisions.
Wi-Fi is not Bluetooth. It's not the same thing.
It kind of could have been. We'll do an episode on Bluetooth because Bluetooth sucks. But now that you divided the band up into 79 channels, what you do is you have two devices that want to talk to each other synchronize their clocks. And then these two devices with their clocks synced exchange a sequence with each other, which says like, all right, we're going to talk on channel 4 for 100 milliseconds. Then we're going to switch to channel 65 for another 100 milliseconds. Then we'll go to channel 19 and so on. And you get to the end of the sequence and you loop back to the beginning. So they're always talking on the same frequency as each other from moment to moment. So they're hopping between frequencies.
But the fact that you have to have a clock for the jumping is this, because you didn't need the clock before, right? So this is starting to get more complicated than just, a car battery at a pole and talking, like this is. It's
orders of magnitude more complicated. You've hit the nail on the head, not just because of the clock, but because of this, because you have to use this algorithm, and algorithms are software, and software has to run on computers. So, but it does get you around the interference problem, because if you're communicating and suddenly you detect interference on channel 24, you can just switch to a different sequence that excludes channel 24 and carry right on communicating.
Was this algorithm and software left to the manufacturers, or was there a spec from the government?
We'll talk about that, but okay. The short answer is the government said, we would like people to develop technologies that use frequency hopping on this range of frequencies. Like that's right. Open to you. You can do that. And then a bunch of companies got together, and a consortium, the one group of people got together and defined 802.11, which is the Wi-Fi spec, and another group of people, which were companies, got together and decided how Bluetooth should work. And then so they ended up with different frequency hopping characteristics and everything.
Right. Because it's like I could assume that the big companies are like, okay, so 0 through 5 is just for us. And everybody else can fight. And so they just basically collude to lock the first 5. Like, this is the AT&T channel. This is, you know what I mean? That kind of thing.
Absolutely.
And then everyone can have the rest. So they just kind of, that would be the normal thing.
It would, like with IP addresses, where Apple was just like, we want 3. Can we just get 3?
I was really waiting to compare this to IP addresses. We could talk more about that.
Yeah,
because this is very much sounding like this. That's a space I know well. This is like, it's the same vibe, right? Like, oh my God, what are we gonna do? We got to control this made up delusion somehow, and then get people to share in this delusion that there's this fences and cows in this place that doesn't exist.
It's so frustrating, Steve. I get so frustrated by it. You're absolutely right. So the FCC looked at frequency hopping and they said, this is great. What if we just take a part of the broadcast spectrum and make a rule that you don't need an FCC license to operate a device that broadcasts on that band? Then companies could build all kinds of wirelessly communicating devices. But now the question becomes, what band do you deregulate? What frequencies are we going to allow deregulated frequency hopping on? Because far from corporate power being what pushes this deregulation effort forward, like I initially assumed, corporate power was a huge NIMBY force here. Many corporations happen to be owners of exclusive rights to bands of the broadcast spectrum, or they had a cartel that owned that broadcast spectrum, right? And they could essentially charge rent on these bands, and that was backed up by a government monopoly. This is what happens when you turn everything into fucking property. You turn everybody into landlords. Now there's ether landlords.
Yeah, rent seeking. What happens at the end? Rent seeking. I mean, this could be about the cloud. I mean, this is the same, right?
Yeah. It goes all the way to the bottom. It goes all the way to the top.
Serious lack of imagination here. Anyway.
Yeah. So these corporations were like, frequency hopping in my frequency band? I think not.
Yeah.
But undeterred, the FCC decided to, rather than go to court against all these corporations, just to use something called the ISM bands. And I won't go into detail on these, but essentially the ISM bands are a set of frequency ranges designated in 1947 for industrial, scientific, and medical purposes, hence ISM. So this band was useful to the FCC because no corporation could claim exclusive broadcasting rights in these bands, so there was no one to complain about the frequency hopping. Do you know by chance why the 2.4 gigahertz band was picked to be an ISM band back in 1947?
Was it one that was being used by someone that vacated or something?
It was being used by people who were manufacturing microwave ovens.
Oh yeah. Okay. Yeah.
Yeah, so they just
the microwave band basically.
The microwave. The first people who made microwaves, they need some frequency for the EM waves to be at, and they leak 2.4 gigahertz radiation. And so the people deciding what bands should be ISM were like, well, we've already got this one that's like polluted with hot pocket radiation, and it's going to be they're going to start selling microwaves to France and China too. So that's already a lost cause. We'll make this one an ISM band.
Wow. So basically, yeah, it was already the consumer electronics using this band for, not for communication, but for, like you said, microwave cheeseburgers at the time, or maybe before,
right?
Like popcorn. But wow, that's crazy. So, but the microwave doesn't interfere, or?
It does. I mean, have you ever? This is less of a problem now, but I certainly had an old apartment post college where every time I turned my microwave on, my internet connection got slower.
Whoa! I mean, we tell ourselves that little screen, the little Faraday screen, is protecting us, but maybe not so much.
Yeah. I mean, it was a shitty apartment with shitty appliances. Yeah. It was probably leaking radiation. Which I'm still here. It wasn't ionizing radiation. How bad could it be? Yeah. So in 1985, the FCC deregulated the 2.4 gigahertz band, meaning you no longer needed a license to operate a radio transmitter on that band, as long as you're using frequency hopping and its transmission power didn't exceed an effective range of about 200 feet. This has been enormously powerful, this deregulation. It gave us Wi-Fi and Bluetooth, like we said, and also a protocol called Zigbee. I don't really know. I think it's got something to do with Zigbee. IoT.
No, it's totally IoT. Like the sort of, and I mean this in the most loving way, but like sort of the Bubba IT folks that like hook like things up in houses and stuff, or what, Zigbee's huge for, if you needed a light, it's sort of that home automation is huge, right? With Zigbee, it's a protocol, like you said. Yeah. IoT.
Got it. Cool. Well, that's on 2.4 gigahertz too. And I can guarantee it uses frequency hopping. That's how it came to be that if you want to manufacture a consumer device that emits radio waves, then you have to use frequency hopping. And I want to emphasize, because this requirement for frequency hopping is fundamental to wireless headphones being so shitty, that this requirement is only present because of the regulation regime, right? It's not a necessity imposed by like the physical laws of the universe. It's imposed by property rights and bureaucracy. A different kind of state, like a worker state or some kind of minimal state, just throwing that out there, could say, listen, the radio spectrum is none of our business. Nobody has the exclusive right to jiggle electrons around at a particular frequency. right? What are you people, crazy? Don't bother us with this nerd stuff. It's 1926, right? Why would I want to babysit your little walkie-talkie club when we could be shooting up heroin with a flapper girl in the bathroom of a speakeasy, right?
Exactly. Yeah. Just take what you need.
Take what you need.
This is the commons, but this is like really insane. These things that we deal with once you start digging in this sort of anthropology of these constraints.
Yeah.
You realize that, it's just the rent-seeking property right stuff on something. Yeah, this is crazy, right? Like it's it's basically like NIMBY in an imaginary place, right? This is incredible.
Yeah,
right?
yeah. Very little. What I'm discovering as I research for more episodes of this podcast is very few of the engineering outcomes that we get, the way that devices at work, has anything to do with how the device would work most effectively or efficiently. It all has a lot more to do with how we organize our society and who has the levers of power.
Yeah. You could almost make the case that all technology and engineering is a space of constraints, that you don't actually build anything or do any engineering. What you're doing is just dealing with constraints from like more authority and things like that.
That's right.
Yeah, it's interesting.
Well, now we come to Bluetooth. And someday we'll do a whole episode on Bluetooth because it deserves its own episode. Today we'll just have a taste. So by the year of our Lord 1994, the promise of spread spectrum technologies had begun to catch the attention of tech industry giants, which were the only companies with enough access to the levers of power, capital, lobbying, so on, to make a profitable investment in that promise. Because if you're going to sell consumer devices that use this band, you need an internationally agreed upon protocol. And it's very expensive to create an internationally agreed upon protocol. It's going to need to use frequency hopping because the FCC says so. So that gives you a place to start. But frequency hopping is just an abstract technique. There's many, many implementation details to work out before you have a usable protocol and you can start manufacturing concrete devices. For example, how will the devices discover each other? How will they synchronize their clocks? How often will the frequency hops happen? How will ones and zeros be encoded into the carrier wave? How many channels are you going to divide the band into? And those are just the technical ones. There's even thornier issues that touch on social organizational questions like how will you ensure all the devices using your protocol follow the rules? Because presumably there will be many companies producing these devices. How are all those companies going to coordinate with one another, and how are their devices going to be certified? And here's another one. If your devices are going to be gooshing out EM waves in every direction, then how will data be protected from snooping? Right? If any data sent over your new protocol can be trivially picked up by a passing rollerblading teenager with a laptop, nobody's going to adopt your protocol. So hopefully this gives some sense of why deregulation of this band was not like a democratizing move. Actually building these devices was going to require an enormous investment, and to justify an enormous investment, you need to expect to realize even more enormous profits. So this was never going to be, the people's band. All right, so in 1994, Ericsson, one of the powerhouse technology vendors of the era, commenced a project that would ultimately lead to the development of one of these protocols, which would become known as Bluetooth. The Bluetooth protocol is absolutely gargantuan, and it really doesn't need to be. But this complexity is kind of part of the point, because the founding members of the Bluetooth Special Interest Group were all, highly capitalized equipment makers. So for companies like those who now had the power to craft this protocol that would govern ad hoc radio communications throughout the world, complexity is good. The more the Bluetooth protocol is needlessly complex and bloated with layers of abstraction, the more demand there is for your chips that know how to speak Bluetooth. The very first Bluetooth-enabled device to hit store shelves was the Ericsson R520M in 2001, but there were no Bluetooth headsets yet. This was a phone, I think. Right, pretty soon you could connect your ThinkPad to that device, or you could connect your car stereo to it if you had a fancy car. Bluetooth headsets did start popping up in the market starting in 2003 with the Nokia HDW2, but these things were definitely not fit for music. These were for talking shit with your law firm buddies while you're in line at the bank in front of Walter White in that one episode of Breaking Bad. They only had one earpiece, and music would have sounded like farts through them anyway because the data rates were way too low.
Right.
And also the chipsets for Bluetooth communication weren't fast enough to decode high fidelity sound in real time anyway.
No. At this time, because I was around, this was not Bluetooth was the sticker that was on everything. And you're like, what is it? Like, I don't know what it is, but I definitely want it on whatever it is I'm buying, right? And this was definitely not an audio thing. Not really.
No.
This was like connecting, more like, you said data, but it was a little bit of the one hand clapping solution looking for a problem, right? At the time. But like, it was like, this is also the Intel inside. This is where they start realizing that slapping stickers on things saying what's inside these boxes is a marketing thing, right? There was a time where it just said internet. Like, this is internet enabled. And you're just like, yeah, the internet is on this.
Yeah, it makes a ton of sense, right? Because if you're a tech company, you don't want people to think of the internet as being what brings them their Amazon packages and their porn. You want people to think it's IBM.
Yeah, how is the market, like, in a way, it's like, this is really down in there. I think this is the first, maybe Bluetooth is maybe a really good example of the first time they are thinking about the technology underneath. Like, this is a protocol or like a spec, like you're saying, a complex, complicated thing. And they're using it in marketing. This is why that Intel inside, or, people were wearing Pentium shirts. Like, what the hell? Like, we're like celebrating now marketing on the things inside a chip or like a protocol. That's kind of crazy. We did not do that before.
Yeah, this one has Bluetooth. That's the best protocol. I read about it in a magazine.
That's what they were trying to do. I think that's the push is wires are out, Bluetooth is in, right? Like, This is the wireless explosion.
It's
with
new.
Wi-Fi
It's big. Yeah, we're always looking for, we can't leave any problem unsolved.
Yeah, especially the ones we're going to make up.
Right. And we can solve those too, and we get paid twice.
Only we can solve this made up problem.
So the technology for music quality wireless headphones really didn't emerge for quite a while. Wireless headphones were out there on the market, but they all kind of sounded like ass. And furthermore, none of them were what we now call true wireless stereo. True wireless stereo, or TWS, is a category that matters because the first Bluetooth earbuds, you don't really see these anymore, but some of the first ones were, I guess, what you'd call false wireless stereo, because they had a wireless connection from the player to the headphones, but they still had a wire from the left to the right earpiece. And the wire.
I did not know that.
Yeah. I think I had a pair of these. It makes sense. The wire is necessary because only one of the earpieces has the actual Bluetooth chip in it. Chip in it.
Controller kind of thing.
And the player would transmit sound over the air to that earpiece, which would then transmit its output to its own local speaker and over the wire to this other speaker.
That makes sense. And so there's like a control, the amplifier, the chip for Bluetooth, all that on one side, and then goes through. I think they still do that even in the buds a bit.
Some of them still do that.
Do you think there was like a long discussion of whether to put it in the right cup or the left cup? And then like in Japan, they were like absolutely left cup, and like this goes on for weeks.
Yeah, and if you go to Japan with your American right cup earbuds, nothing where
work.
All the sound comes out backwards.
Works. It's like it comes out backwards.
I want to point out that this configuration where the two earpieces are connected by a wire actually has a significant advantage over true wireless stereo, which is that it makes synchronization between the two earpieces trivial, which you need for stereo playback. Right? I'm sure you've had the experience where you're listening to music on your wireless headphones and then suddenly the two earpieces get slightly out of sync from each other. So you're hearing the right channel like 50 milliseconds later than the left channel or something.
My God, I didn't need that MRI. I thought that was my head. Like,
it's so jarring, right? It feels like your brain is melting for like a split second when that happens.
For sure. If it was like you brought up Zuckerberg, if it was the glasses, you'd crash your car. Like, this is no joke. Like, this is your senses, your first order perception.
Oh, you won't need to drive your car anymore because the AI is going to drive your car too.
I mean, this is that thing where, like, when it's happening, you have to go to someone else and say, do you also hear that? And then that friend's going to be like, oh, I don't know. It sounds fine to me. It must be your head just because they're messing with you, right?
Yep.
But this is literally like your foot has left the frame of reference. How would you know that the audio's out of sync. I think people had this experience, but they didn't know what it was, right? Like this is takes some like real thinking to think about what's happening. And you thought you were just plugging in some headphones.
Exactly.
Right? This is wild.
Exactly. And it can only happen with true wireless devices. The left and right earpieces are communicating wirelessly, which means one side can get hit by interference and has to renegotiate its frequency hopping sequence. So it gets a little behind for a little while until it gets resynchronized. All this is to say, I never trust the technology industry when they say that a new advancement is a pure improvement over the thing that came before. Like when they said, true wireless stereo is here, finally, no more wires. That there's almost always something important and good that is sacrificed at the altar of newness. And of course, the marketing's never going to mention that. And now I want to talk about one of the biggest problems with wireless headphones in general. Namely, compared to their predecessor, the wired headphone, wireless headphones use a shitload of energy. Why do they use all that energy? Can't they use less energy? Well, no, for two reasons. To understand the first reason, let's think about how simple a device a wired headphone is. Inside the earpiece, you have a flexible diaphragm. A diaphragm is just like a circular piece of plastic that can stretch a little like your eardrum, but made of plastic instead of whatever your eardrum is made of. Bone, skin,
bone, cartilage.
I don't know biology. This isn't biology blows.
Yeah. Body stuff.
Yeah, body stuff. It's made of non-body stuff. And attached to the diaphragm is a permanent magnet, just a small hunk of metal that's magnetic, that's like glued onto the diaphragm. Right next to that is an electromagnet. And the electromagnet is simply a magnet whose field strength varies with the amount of current you put through it. A less current, weaker magnetic field, more current, stronger magnetic field. And this is pretty much it. Because as far as the electronics inside a headphone go, there doesn't have to be a microcontroller inside a wired headphone. The player just, unless you're doing noise canceling, right? The player just puts a small voltage on the contacts of an 1/8" audio plug, which induces a small current in the circuit. The current carries a small amount of power to the electromagnet so that the electromagnet's magnetic field varies over time with the waveform of the music. That makes the permanent magnet vibrate. That moves the diaphragm, creating pressure waves in the air, and we're done. Because pressure waves in the air are what sound is. No software whatsoever is involved.
Yeah, so to record, like a microphone is the speaker in reverse, right? And so it's
exactly a speaker in reverse.
You're moving the magnets, but it makes the plastic thing jiggle, and that's how we hear. But you could do this at a distance. You have the headphones where you're listening to the music at a distance kind of thing. You don't have to be there. I mean, distance as in maybe even a different time than it was recorded, right? Like, and so this is what's cool.
Yes.
Is you're moving something, you're remaking the sound waves themselves in a different place or time through a wire, that was the whole thing. It's incredible.
It's incredible. And we had nailed this by 1930.
Yeah, this is old. This is over 100 years now. Yeah. The idea of wireless, as a musician, say, you want to be able to run around anywhere and still rip the solo. Like, you know what I mean? Be in the crowd, like do all this stuff. So it's that freedom of movement. But what I think we ended up with what you're saying is basically just like a wireless wire, like a digital wire, you're just as tethered. Like this isn't the freedom that you imagine or were promised. I wanted freedom to move around, like I really want to leave the player at the house and go as far as I want, but I'm still tethered. So that didn't pan out. The untethered didn't pan out.
I think it did not solve that problem for us.
Yeah, it did not solve that problem. But I think there is a contingent of folks that were like, I want to be able to move freely. And instead, I feel almost, not only am I just as tethered, I might actually be technologically at a disadvantage here. Like this is more complicated and it uses more power. And that power is for that precision of the bits, right?
And it's possible also to forget. So like if you're playing music for a party through your phone and it's right next to this Bluetooth speaker, and if you had a wire, you can't forget that your phone is playing the music, right? But if you're connected with Bluetooth, it's very easy to just pick up the phone and go to the bathroom and then the music stops playing. Yeah.
Yep.
Yeah, it did not solve this problem for us, and it can't, because a wireless headphone needs a little computer inside it, because Bluetooth.
Yeah.
The wireless headphone has to communicate with the player over Bluetooth, and that involves a ton of computation. So first of all, you got to do frequency hopping. You can't do frequency hopping without a computer. How would you do it, right? It's a complex, abstract algorithm involving different phases of operation, exchange of coded sequences, stuff like that. It's software. You need computer hardware to run it. And another thing you need a computer for is you have to decode the sound data. Remember, in wired headphones, the signal is just an oscillation in the voltage differential between a pair of wires. The headphones don't have to do any work to decode this oscillation back into sound, because that's handled by the laws of physics, because of how the headphones work. But with wireless headphones, the situation is totally different, because it's digital, not analog. So the player can't just do frequency modulation like Planet Radio 93.3. It has to digitally encode the sound and send it over the air in discrete packets.
This changes everything.
Changes everything.
This is the whole, that like how it comes in, how it comes out is everything. Like, thanks to Mr. Shannon, this theory of information and channels and digital is a completely different thing.
It's a completely different thing
with the wire. And in mentioning even software, there's also not just the negotiating and all that. There's the software development lifecycle, which is who's writing this software. Now, this whole, the grandpa yelling, wait, I got to update my headphones. Like I bought a motorcycle, and the first thing I do is put a USB in it and update the system. This is insane.
It sucks so bad.
If you remember the other thing, but this has become normalized that the first thing you do when they open the boxes, it says like turn them on and connect them to something and update. And so now we're also eating a software life cycle, not just the hardware, but now this whole other world of the thing where at some point the headphones don't even work. You bought these headphones. Now you also bought a relationship with this company. You bought updates. I have to be somewhere where there's communications before I could even use. I mean, this is like, that just slid right in there. Whereas before it was like you plug the thing in and it worked.
Yeah. So yeah, you got to encode the sound. You got to chop it up into discrete parts. Then you got to analyze each part and reduce it to some combination of numbers and metadata. And you probably also compress the resulting data. And then you have to do that something like 44,000 times a second. So it's pretty fucking computationally intensive. And then on the other side, the wireless headphone has to decode all the data back into an analog signal. So, decompress it, transform the numerical data into an analog voltage, and apply the voltage to its speaker. And it has to do all that just so it can drive the speaker and approximate the sound of "This Is What It Sounds Like" from K-pop Demon Hunters to make your child dance. And all this decoding has to be done by computer software, which necessarily draws power. So that covers the reasons why wireless headphones need to draw so much power, because they have to have this computer inside them. But I want to talk about one additional reason why wireless headphones suck power out of your phone. And sometimes people turn off Bluetooth because they have heard that Bluetooth, when it's just on in the background, uses power, and they want to conserve their battery life. Not really true. I looked it up. Yeah. It's fine to have your Bluetooth on in the background. However,
I mean, I was at Berkeley Bowl and they told me it was poisoning the vegetables if I could keep my phone away from the vegetables. But yeah,
the vegetables love it. They're listening. I'm broadcasting. I got a like playlist on.
It's getting the Wi-Fi and the Bluetooth are getting in the food. Yeah. Anyway,
we can't call it organic anymore. It has 2.4 gigahertz radiation in it.
Can you please go to the other section where we don't care what waves are going on the food?
Yeah, you can do it to the potatoes. Potatoes are fucking idiots. They're
dirty, dude.
So when you play music to wired headphones, all you have to do is continuously vary that little voltage differential across the tip and the sleeve contacts of an 1/8" audio plug. Physics handles the rest. When you want to play music to wireless headphones, instead of a wire, you're using an antenna. So a 2.4 gigahertz antenna is a component integrated into your smartphone. It's about 3.1 centimeters long, which is a quarter of the wavelength of 2.4 gigahertz radio waves. Now, of course, the smartphone doesn't know where your headphones are. They could be left, right, up, down, 1 foot away, 20 feet away. It doesn't know. It can't know. Therefore, the antenna is omnidirectional. It just barfs out energy indiscriminately in all directions like Linda Blair in The Exorcist, and only a vanishingly tiny proportion of that energy actually hits the antenna in your headphones. All the rest of it gets radiated off into space, or like collides with the pipes in your wall and heats up your water very slightly, or vibrates the metal fillings of your downstairs neighbor and makes him think the government's sending him secret mind control codes. So as opposed to the wired situation where almost all the power is supplied to the wire gets into the headphones because, you know, it's a wire. When you're transmitting to wireless headphones, you have to pay for all this extra wasted transmission power. It's just like, oh, maybe it's over there. It just sploosh.
So it's just going to blow your battery trying to find your headphones, basically.
Absolutely. Yeah. So all this is to say, wireless headphones suck down a lot of power. And if you can't get power through a wire and you need power, what do you have to have? That's right, a battery. A battery in your headphones. A battery in headphones is shit that no engineer would ever think of on their own. If you just told them to figure out a way to get music into someone's ears, it would never occur to somebody. In order for this idea to even occur of putting a battery into a pair of fucking headphones, there needs to be an entire electronics industry. You need global supply chains, international protocol agreements. The entire weight of the worldwide legal and policy apparatus has to be concentrated onto, in the form of project constraints, onto companies' R&D departments. When all I was trying to do is listen to Bauhaus while I walk my dog. Yeah. So to return to my concrete headphones, wireless headphones here, which are these JBL Live Free 2s that died in my washing machine. These are supposed to be charged in a little snapshot charger case with little earbud-shaped charger grooves built inside it, which plugs into the USB hub on my desk. And this charging case is actually pretty slick. It feels solid. It feels well designed. But then I remember that the only reason the charger case had to be built is because headphones need to be charged now, which is fucking stupid.
Right. It's like we got rid of the wire just to get it back with the battery.
Right.
What the fuck?
Right.
What the fuck? There's no net gain here. It's wireless headphones, except I always have to plug them in for the battery that was supposed to. This is literally the ship with too many guns, like that just sinks. Like you're always plugging it back in because the battery to get the wireless experience for a short bit of time. What the fuck? Good job, guys.
Great job. Great job, Erickson. It used to be the process was simply plug your headphones in. When you're done, unplug your headphones. But now it has to be like, keep the headphones charged and you got to plug them in when you're not using them. And if you forget to plug them in, maybe because it's inconvenient to always bring your headphones to the same place in your house when you get home, then sorry, you're not listening to music today, buddy. Your headphones are out of battery. Oh, also, if there's a problem with the battery or the microcontroller or any of the other components, your headphones have just transformed into shitty earplugs. Go buy a new pair of headphones.
This would not. So back to the podcast, the first one. This would not pass the military thing. They would not buy these. Not like Baldwin. They would not sell. This does not pass any kind of like rigor, because if for any critical situation, you can't be like, wait, did you say fire? Do I have authorization to fire from the Black Hawk? And you're like, hang on, I got to plug my other, meetings, and they pop the battery out, put another, like, hang on, you still there? Right? Like,
Yeah. Can't you imagine a world where this tech never came into existence and we just didn't have to spend our precious attention on charging our headphone batteries? Like, all that human effort that went into inventing and building and marketing these things could have gone into some other activity. I don't know, pottery, mountain biking. And I think we'd all be happier. So in September of 2016, Tim Cook, the incredible visionary Apple CEO who took the reins from Steve Jobs and produced such magical innovations as exploiting Chinese labor harder and smelling like a normal human instead of the dumpster behind a fish market. Seriously, look it up. Steve Jobs smelled crazy.
Really?
He didn't believe in, he followed this like mystical diet.
Oh, yeah,
and he never bathed because it would, I forget what the details were, but yeah, look
Mao.
It up.
He's like Mao. Yeah. Steve Jobs and Mao.
Did Mao smell crazy? I didn't know that.
Yeah. He wouldn't shower either. I guess that's like the ultimate privilege, right?
Yeah.
Like grooming and bathing. I mean,
I don't have to care.
No.
Yeah. Anyway, Tim Cook gets on stage, and it occurs to me I don't actually know what Tim Cook smells like. He might not smell normal either. You can't tell from. I couldn't tell from the YouTube video.
Yeah, this is that privilege, right?
Right.
A lot of famous people right now are like rumored to smell terrible. But the interesting thing is you have to get close, right?
That's right.
There's no like Bluetooth smelling, right?
Just rush the stage at the next Apple event and give him a good sniff.
Give him a good sniff. Sniffing Tim Cook.
So he walks out of the stage to fanatical applause. I watched the whole Apple September 2016 event for research, and I knew early on that I was in for a real depressing hour when he's reading out his amazing lineup for the 10th anniversary of the Apple Music Festival. I'll let Tim take it away.
This year includes Elton John, One Republic, Robbie Williams, Britney Spears, and so many more great artists. It's going to be amazing.
It's going to be amazing, Steve. Quick question. Do you think Tim Cook has ever listened to music?
No, I don't think he's much into music.
I don't think.
But maybe. I mean, well, I would say, I would venture further, said he listens to it, but he doesn't hear it.
Yes, he's probably the guy who has the radio on all the time, and it's just background noise.
He doesn't sing. Yeah.
He'll sing along
maybe,
to.
But you could just find out.
He'll sing along to, We Built This City or something. They talk about the Apple Watch for a while. They say, we think the Apple Watch is the ultimate device for healthy life. Isn't this great news, Steve?
Yeah, I can't believe I'm alive without one.
I know. I thought my health was in the shitter because I eat mac and cheese every day and I don't exercise and I smoke too much weed. But it turns out all I needed was to buy an Apple Watch.
Yeah, maybe two. One for each hand.
Then I could be twice as healthy.
Wrist. It just works like that.
Just fuck off, man. You can't sell me a healthy life. You break. The important part for our purposes happens around minute 59 of the event. They get to their little Westworld intro sequence looking ass iPhone 7 design fly through, and you can briefly see the iPhone 7 does not have an 1/8-inch audio jack. The bottom of the device just has speakers and a lightning port. But of course they don't mention that during the keynote because why would you announce something that you can't spin as an improvement? So you might ask, if the iPhone 7 doesn't have an audio jack, how are you going to play music from it? Well, dumbass, just use Bluetooth. Or if you're some kind of cave-dwelling technophobe who probably thinks Bluetooth radiation is going to like mutate your sperm into a boomerang shape so they fly back at you whenever you ejaculate, then I guess you can spend $20 on this little lightning to 1/8-inch audio adapter that costs Apple pennies to make and will absolutely break or get lost within minutes of being removed from its packaging. So don't worry, you'll still be able to listen to the mediocre U2 album that comes burned indelibly onto your motherboard.
Why? Why the fuck did they do that? Why?
Well,
Why?
let's talk about why. So thank you for asking. Because
that was honest. Why the fuck would you do that?
Yeah, I wondered the same thing. So the removal of the 1/8-inch audio jack got a lot of people talking, and I know at least some people for whom this was the final straw, and they just switched to an Android phone and never went back. You'll hear Apple apologists say that they removed the 1/8-inch audio jack in order to make the iPhone thinner. But if that's the case, and if thinness is so important enough to justify such a radical and unpopular move, then why didn't iPhones get thinner? The iPhone 7 was 7.6 millimeters thick, which is 0.2 millimeters thicker than the iPhone 6, which had an aux port. And iPhones have just kept getting thicker since. I'll post a graph in the episode notes. The iPhone 16, which came out in 2024, is 7.8 millimeters thick, which is almost a whole millimeter thicker than the iPhone 6, which was the last one to have an 1/8-inch audio jack. So the thickness rationale is transparently bullshit. Now, another thing people will say is that the 1/8-inch audio jack was removed in order to make the iPhone more waterproof. And you got to admit, it's pretty convenient for a smartphone to be waterproof. I'm clumsy enough that this matters a lot to me. Before they invented the waterproof smartphone, I was spending like 5% of my paycheck just on rice to get the water out of my phones that I dropped in lakes and rivers and things.
This is the thing I was going to say. That would be my top theory, is that waterproof. They had some board meeting inside Cupertino somewhere, and they said, you know what people want more than a headphone jack is waterproof. And I do think that makes sense, but you're about to tell me other things.
It makes a ton of sense. Waterproofing
makes total
is
sense.
a very solid rationale. If you had to get rid of the 1/8-inch audio jack to make it waterproof, that would make sense to me.
I expect the phone to be waterproof. I mean, honestly, like, this is ridiculous. You know, like in the 80s, you'd get pushed in a pool. That'd be like $1,000 thing now.
Everybody was always getting pushed in pools in the 80s.
I know, like, everyone's pushing in pools and going on water rides. No one was worried about their phone. I mean, if you're going to have a human carry something, it needs to be like, not water, just liquid proof, right? We're kind of, we're like fish that walk around.
We're made of liquid.
Yeah,
we're made of liquid. There's liquid all around all the time.
Just fast liquid, slow liquid, right? But like, basically, like, to not have the phone waterproof makes so much sense. So I imagine, I guess I made my own narrative that it was to make it more waterproof, and I don't even think there are.
I don't think so. There's no reason that you can't have a waterproof phone with an 1/8-inch audio jack. There's the Galaxy S5 has one. The Nokia XR20 has one. That's a really heavy duty phone. There's nothing about the standard of the 1/8-inch audio jack that makes it impossible to seal against water leakage.
Right. That's what. Yeah. It's just 2 pins.
It's just pins. Throw three pins. But still, like, there's nothing not waterproof about the fact that it's round or the fact that it's 1/2 an inch long, or I don't know. It smells like bullshit to me. I think the real reason that the 1/8-inch audio jack was removed from the iPhone was market creation. The iPhone 7 was coming out at a time when wireless headphones had become easy to mass produce and could finally play music that sounded kind of okay. But the adoption of wireless headphones was lagging. Everybody already owned at least one pair of wireless headphones, and unfortunately, these are generally inexpensive, durable, and repairable. Wired headphones were good, and people liked them. And when a technology is good and people like it, it must die. Consumer satisfaction is the tech industry's worst enemy. Wireless headphones are in a lot of ways a perfect innovation for the big tech companies. They're the opposite of wired headphones, which are long-lasting, easily manufactured, and based on universal physical laws. Wireless headphones are a fully encapsulated device. If anything goes wrong with any of the connections or the chips inside, they instantly turn into garbage, and you have to pay Apple or whoever another $200 for a new pair. Wireless headphones are not, like wired headphones, a product that anybody can just jump into the market and start making. I mean, think about it. Without a massively complex supply chain and without access to extremely scarce engineering knowledge, it can't be done. The only competition wireless headphones have to worry about is competition from other huge tech companies, and there's only a handful of those. So that complexity, the complexity of the wireless headphone tech, is a natural moat that protects the Sonys and the Apples of the world from competition, and it also makes sure that everybody has to buy a new pair of wireless headphones every couple years.
That was the conversation after lunch in Palo Alto or Cupertino or whatever. That was the conversation.
Yes.
Like, we need to moat. We need walls, right? Like this, but nothing beats like obfuscated software, right? Walled garden kind of stuff, right? Like, and so you're eating their whole. The other thing is, I think that they love the fact that they can. You do have no control digitally or technically from the phone over an input jack. You have no control. There's no control in this thing. You can't turn it off. You can't degrade it. It's too perfect, right?
That's right.
But moving it into that digital supply chain, right? This software supply chain, now they can actually control that. Now they can control bit rates and things, and they can charge. Like, I mean, this is happening everywhere. You could buy a BMW and you can't go fast without the upgraded software, right? And so this is the whole market. Like, yeah, well, there's KTM famously not only got rid of the key with the key fob, they got rid of the off-road mode until you actually like upgrade it. And so literally you have to plug a USB key into your
fucking
at
God.
the dealer. They have to plug in a thing like a hard drive. And all it does is flip a couple, like I always think of them as dip switches inside your motorcycle to turn on that mode. So this plug is a huge problem for them in terms of like ubiquitous access to analog as in non-digitally controlled content.
Yeah.
Right. This is what I was saying. Like the technical object is increasing, right? But people aren't seeing that. And so when you say like, wow, I just want to listen to music, or I have a phone. I didn't know I also have to eat like a technical supply chain. So when things go wrong is when people notice. Again, you're at the airport when what was that outage with the CrowdStrike and all the screens turn blue. People at the airport like, what do you mean? I see the plane with my own eyes right there. We could all get on it and go in the sky. And they're like, no, this computer over here is not working. And just the angry response, like, what do you mean? I can see the plane. Like,
Right.
What does this have to do with that? Our understanding was the plug was for listening, right? I agree about the beauty of the plug. You just plug it in. I like the wire. There's something certain about that. What they're doing is putting it behind this whole software thing. It's a completely different technical object. You're accepting something completely different, and it's coercive in that way. It's not. You're not even getting a say in it. It's a coercive listening experience.
It feels superficially like the same technical object, and you're encouraged not to think too hard about the way in which it's different.
You killed our friend.
Yeah,
you killed our friend. The headphones.
I know. They killed our friend.
Like just gone.
Yeah,
just not.
Nothing we could do about it.
Out. And in the way that you're doing this arc, like from the 70s, there starts to be this change from like, it almost is this like folksy, like Sesame Street cartoon of the headphones and the player working together. It's a conversation. It's a cooperation. This is a completely different thing where you're eating all these other players that you don't know about. Like, it is not simple in this way at all.
That's right.
The minute you add a computer to anything, you're eating something immense. From the naivety of doing, database records in medical that we did in the 70s and 80s, just this is a completely different thing you're eating.
The computer becomes and a completely different thing that ends up eating you.
Absolutely. You might be, you're like, it's not just a phone anymore. There's like a black hole inside the phone of just depth of something that we're not really ready to understand and talk about yet. And moving music digitally like that. What a bold move, though. Bold move.
It was a bold move.
Bold.
It was very bold. I wish it hadn't worked out so well for them, but it did. Yeah. Wireless headphones are just one of the many ways that the free market, contrary to what all the Milton Friedmanite neo-lib talking head dweebs will tell you on fucking CNBC or whatever, the free market consistently produces antisocial, anti-human outcomes. Anyway. Alienation. Yes.
So that was alienation. Like I am like music, and you're deleting the way that I do it and making me do something else on your terms coercively. And now, every time I want to listen to something, I have to do this other thing that I didn't understand to be part of this. And it's alienating. Just like if I used to make the wheel at the factory. Now they come in and they say, this is how we're doing it on the computer. We've optimized it. Now you just make these less motions. I don't like this anymore, right? I don't like it.
Well, welcome to the show, Steve.
Yeah, you got me going.
I got you. I knew you'd be the right guy. So anyway, later in the Apple 2016 September event, Tim Cook announced his beautiful new shining white baby, the AirPod. Do you own a pair of AirPods? I don't.
Not Apple.
I don't have them.
But yes.
By most accounts, they're good. I don't know. Tim Cook makes a lot of hay with this new W1 chip during the talk, which has been supplanted, but it lets them pair. It's supposed to let their AirPods pair with Apple devices really easily. I think by designing their own custom silicon, they were able to circumvent and supplement a lot of the Bluetooth logic because they control both the iPhone and the AirPod. I read that there's digital signal processing built into the chip, at least in the H1, which is the successor of the W1. So maybe I think because they control the transmission properties of all their Apple devices, they can get a cleaner signal on discovery and for transmission, because like the more precisely you define the channel, the more you can distinguish signal from noise.
I would venture to say that it's not even Bluetooth anymore, because there's no way to actually observe this. Like because you can't use those pods with other devices. Can you hook up Apple AirPods to any generic Bluetooth?
You can. They do have Bluetooth.
Then it is. Okay. But I could see them being like, they only work with our phones, and then at that point, yeah, they might have their own protocol at that point. Which would make sense for them. Maybe that's next, to delete the Bluetooth too.
Yeah, they've extended the protocol somehow. I mean, they don't publish the stuff,
tell, right?
But you know, if it were me, I'd be like, we can get a sort of a signal boost or a noise suppression by the fact that we know all of our MacBooks and all of our iPhones are going to use the same clock, you know, the same clock speed and the same, the same noise detection algorithm. And so, you know, you can sort of tune them, mold them to each other to get a stronger signal.
This is that e-shitification that Cory Doctorow this gets into this.
100%.
The feature, right? The feature is sold as this. So yeah.
Yes. Right. And when they start doing things that have no benefit to consumers or their partners and benefit only Apple, that's shitification.
Especially clear.
Yes.
Yeah, especially clear here because we're still under the multi-purpose computer, right? Like, I mean, calling it a phone anymore is even silly. But if we were calling it in this stream, we're calling it the Walkman, okay? And so we replaced the sort of cassette-based or CD-based, even that was different, but cassette-based, plug-based, magnetics and physics-based device with now a multi-purpose computer, very much like the Turing computer or the von Neumann computer or whatever, right?
Yeah.
And so this is a completely different game. And then in that realm, it's basically defined not by the objects themselves, but informationally inside the generic sort of sand we've turned into light switches. So that once we go into the bits and bobs, and what we're saying, me and you were saying, is we don't see the music listening device, right? Like literally They even removed it, and they're forcing us to see it in more of an abstract way. That the fact that almost music comes out as a side effect for them.
That's right.
The fact that almost doesn't matter.
Yeah, it wasn't a side effect to Nathaniel Baldwin. He just wanted to listen to sermons about how everybody should have enough wives to start a basketball team. But Apple, to Apple, it's not. There's no the this is all changed in the 70s, like you said. But there's what they want is for profit to be generated by people buying their headphones. And if people like music, great, we find a way to turn that into people paying us for hardware. So for wireless headphones, the AirPods are, by all accounts, pretty good. And if you don't want AirPods, there are plenty of other Bluetooth headphones to choose from. Sony makes them, JBL makes them, LG makes them. Pick your favorite multinational tech conglomerate. But by virtue of the relative goodness of the AirPods, they mask the underlying irreducible badness, or at best pointlessness, of the whole wireless headphone project. Because it can't be denied that wireless headphones have solved some of the problems with wires. Namely, they sometimes get caught on things and they're kind of a pain to bundle up and shove in your pocket. But in creating these wireless headphones, we have taken on a bunch of other problems that range from difficult to physically impossible to solve. And while we were at it, headphones went from being a very simple piece of technology that you could build in your spare time while operating hydroelectric dams in West Fuckburg, Utah, to an artifact whose basic functioning depends on the cooperation of massive profit-obsessed technology firms, and by extension depends on the entire apparatus of the regulatory state. They don't have to be this way. Wireless headphones don't have to be this way. We could have headphones that use AM or infrared, or we could have a weird heterogeneous market of a bunch of different technologies. But instead, we've built capital accumulation into the device. We have taken capital accumulation for granted and worked backward from there and got Bluetooth headphones.
Made the chain invisible.
We made the chain invisible.
Made the chains invisible. I wanted no chains, and what I got was an invisible chain.
Yeah, this way you don't have to look at the chain.
That's not what I meant. Yeah. You're just as captive with wireless headphones. This is just an invisible wire.
We can't go back, right? The consumers don't have a say in how the private industry spends its R&D budget. Suppose you went back in a time machine in 1991 and appeared in a cloud of glitter and starlight in the office of CEO of Ericsson Mobile, right as he was signing off on the research project that became Bluetooth, and you yelled, "Stop! Listen to what I say! This Bluetooth will take on a life of its own, and though it will make billions, perhaps hundreds of billions of dollars for you and your investors, in the universe that I come from, it's the cause of mass daily inconvenience, wastes of time, wastes of money, wastes of energy. People hate it. It causes confusion, anger, and despair. It's a bad technology that makes people's lives worse." The CEO of Ericsson would be like, "Yeah, man, that sounds awful. Can you go back over the part about the billions of dollars, though?"
Yes, exactly.
Not that I want to go back. I don't want to go back. Right. I'm not
going back.
I'm not foolish enough to believe that the 80s were an objectively better time because we had wired headphones. But I hope that people find and figure out the pieces of this that are better and embrace that.
Yeah. Yeah. I think that there could be a future where we learn from some of the things we did. And just because you're in something doesn't mean that's forever. And I think the other thing is there isn't an inevitability to this at all. Apple wants you to feel that there's an inevitable progress to less and less wires and thinner till we just disappear. And like the watch itself is making you thinner, everything's thin, and then we just disappear into a line. But effectively, I think that inevitability that they preach, especially big tech, is not a thing. It doesn't have to be that way. You can still have wires on your headphones.
Yeah. Throughout the whole process of these devices coming into existence, there were many, many off-ramps and decisions that people made that they didn't have to make, that were not constrained by the physical needs or even the needs of the market, that were constrained by regulation and property law, which are all contingent. Those are all human generated things that we've decided together to live with. And my perennial hope is that we can wake up one day and stop doing things we don't like doing.
Yeah. It's a beautiful thing, the becoming. The wired headphones is not dead. It's becoming. It's still becoming. This is a conversation, right? The becoming is still going. So I believe that we're still very much in this conversation about headphones.
Well, when they go back to being good, I'll issue a retraction on this episode. Steve, thank you so much for being here on the show. Are you sure you don't want to plug anything? Give our audience any parting words?
No, man. Thanks for having me on. You can find me on LinkedIn if you want, or I'm around, but I'm not on social media as much and stuff, so there's not much to plug.
Go out there, check out Steve. He's very funny and smart. Awesome. I'm right back at you, Steve. All right. Well, this has been Technology Blows. If you like the show, tell your friends. Give us a 5-star review if you got a second. It'll help us tremendously. And until next week, I'm your ever faithful host, Dan Slimming.